Good day, welcome. Today we will be looking at calculus, but more specifically differentiation from first principles. What is the first principles of calculus? It is the slope of a curve as derivative. This is called differentiation from first principles, or the delta method. It gives the instantaneous rate of change of y with respect to x. This section looks at calculus and differentiation from first principles. Differentiating a linear function. A straight line has a constant gradient, or in other words, the rate of change of y with respect to x is a constant. We will look at differentiation of a few simple curves and also use the function notation. Calculus has to do with the rate of change of y with respect to x measured at an instantaneous point. At this point in time, we should be familiar with all of these in the progression of gradient. We've heard that gradient is equal to delta y over delta x. We've heard that it is the change in y over the change in x. We've heard that it is y2 minus y1 over x2 minus x1. And for those who have forgotten, last year you were introduced to a curve function where you had to calculate the average gradient between 2 points, and you used the function f of x plus h minus f of x over h. Now we say we have a problem if h becomes 0. So now we will look at the limit of f of x plus h minus f of x over h as h tends to 0. What are we talking about? If we have a curved graph and this coordinate here is x and the distance between the 2 points is h, then this point over here will be x plus h. And if I plug it into the function, I substitute it into the function, I will get f of x, the function of x. And if I put this into the function, I will get the function of f of x plus h. So we notice that the distance between 2 points, we can find the gradient of the line between those 2 points. We can take those points closer to each other and we can calculate the slope between those 2 points. But in calculus, we refer to getting that instantaneous rate of change at a given point. So here, the line has become a tangent to the curve. Hence we say the distance between the 2 points tends to 0 when there's no distance between the points. It gives me a tangent to the curve. In our first example, they expect of us to calculate using first principles the derivative of the function. Here the function of x is equal to 4. So if I have to calculate f of x plus h, there is no x to substitute, so my value will be 4 for both of them. So when we work with the function of the derivative, we write it as follows. F prime x is equal to the limit of f of x plus h minus f of x over h. as h tends to 0. Now we substitute in the place of f of x plus h, we substitute 4, and in the place of f of x, we substitute that 4. So we continue to say f prime x is equal to the limit as h tends to 0 of 4 minus 4 over h. What happens now? 4 minus 4 is 0. 0 over h. Thus f prime of x is equal to 0. Thus we can conclude a whole number, when it is differentiated, is 0. Thank you for watching this video. We will see you in the next one. Goodbye.